So in our second example, we want to use absolute values to determine the distance between each number. And if I asked you nice numbers like 7 and 4, what's the distance between 7 and 4? You would do 3, right? And you probably just did 7 minus 4 in your head. So when you're asked between the distance between two numbers, you always do the bigger number minus the smaller number. Does that make sense? Like, what's the distance between 100 and 80? It's 20, because I do 100 minus 80. Sometimes when we're dealing with positive and negative values, though, you might forget which one's bigger and which one's smaller. Right? It's not hard with 7 and 4, because you can automatically see that 7's bigger. What would happen if you did the smaller one minus the big one? What's 4 minus 7? Negative 3. And the distance between them is actually 3. What happens if you did 80 minus 100 instead of 100 minus 80? You get negative 20. So if you didn't know which one's bigger, right, negative 3.7 and negative 8.5, and you just subtracted them, you might accidentally do the smaller one, subtract the bigger one. But if I put absolute value bars around it, it wouldn't matter, because then you would make your answer positive in the end anyways, because 7 minus 4 is 3, and 4 minus 7 is negative 3, but if I change that to positive, the distance is 3 between them. So if you don't know which one's bigger, right, you could just say, oh, I'm going to put absolute values, and I'm just going to go negative 3.7 minus negative 8.5. In this case, did I choose the right order? I did. Negative 3.7 is bigger than negative 8.5. With absolute values, though, I can't just change all my signs to positive. That's the number one thing students want to do, because they have in their head absolute values change things to positive. That's only true after you've simplified it and you have a single thing inside. So once I have a single thing inside, then I can do that. So here, subtracting a negative, would you agree that that's positive? That's adding. And negative 3.7 plus 8.5 is going to be 4.8. And what's the absolute value of 4.8? It's just equal to 4.8. So would we have needed the absolute value bars at all in this question? No. But had we done the small one minus the big one, it would have fixed that for us, and we wouldn't have done anything wrong in our work all the way through. Perhaps in B, it's really easy to see which one's bigger. Which one's bigger, 4, positive 4, or negative 5? So in B, the positive number is bigger. So you know if you would start with 4 2/3 minus 5 3/5, your number is going to be minus a negative 5 3/5. Your number is going to be positive. But this is a good question because it really practices your fraction work. First of all, minus a negative. I could put absolute values since it says we should use them, even though we won't need them. How would you add those numbers together? What were your techniques that you learned back in grade 9 for adding fractions? Yes?
4 times 3 would be 12 plus the 2 would be 4 over 3.
Okay, so you want to change this into an improper fraction, and this one will be 25 plus 3, 28 over 5. Okay?
Make the bottoms equal, so times it by term.
So we need to make the bottom numbers equal. 5 times 14 is 70 over 15, plus 3 times 28 will be 84 over 15. And then you could add those together. 154 over 15. If you wanted to change that back, there's 10 full 15s and 154, and there's 4 left. Did anybody learn other ways for adding mixed fractions? Or is this the way everybody learned? Okay? Improper fractions are good. I like them. Okay? If I was adding these together and I didn't want to deal with as big of numbers, 4 2/3 is like 4 plus 2/3 plus 5 plus 3/5. Would you agree that 2/3 is equal to 10 over 15? And 3/5 is equal to 9 over 15? Did I get a common denominator between those two? If I add those two together, do you see you would get 19 over 15? If I add these two together, do you see that I would get 9 plus 19 over 15? 19 over 15 is 1 4/5. 9 plus 1 4/5. 4/15, sorry. You can add fractions, mixed fractions that way as well. Okay? The nice thing about what was done on the right is we didn't run into very many big numbers, right? Like here, I had to multiply 14 by 5. I don't know how good your 14 times table is. Here you had to multiply 28 by 3. How good is your 28 times table? So you deal with the mixed like improper fraction, and I always change to improper fraction. I always do this. I think everybody's taught to do that. Well, you'll have to deal with bigger numbers. But it could be that you decide to work with the smaller numbers, and it works as well. All right, questions for practice on this one are 5 and 8.